2, 1, and here we go. All right, so we are transitioning, ladies and gentlemen, over to our geometry units. Okay, now every single school year has a geometry unit of some kind. Okay, the only thing that really changes from one year to the other is the shape or shapes that you end up studying. So, if I remember everything correctly, okay, in 7th grade, and possibly 6th grade too, the big shape that you spend most of your time on is the circle, right? And you talk about circumference, you talk about the area of a circle, you talk about the radius and the diameter, you talk about pi. Do these terms sound familiar to you guys? Have we studied the circle at some point and heard these terms before? Come on, folks. Yes or no question. Doesn't take that long. You have never learned about the circle before. Interesting. Okay. Well. Doesn't ring a bell. No, yes, nope. Okay. If you have not, that's okay. I've included a slide here that has all the important information that you'll need to know, because circles are an important part of the shapes that we deal with in 8th grade. Okay, now in 8th grade, we do not deal with 2-dimensional shapes, we deal with 3-dimensional shapes. Okay, and we are required to learn how to calculate the volume of cylinders, cones, and spheres. Okay, and thankfully, you guys already know the majority of what you need to know in order to be successful in our geometry unit. Okay, there's a lot of work with decimals, which we've reviewed. There's 2-step equations and inverse operations, which we just finished reviewing. So you guys know how the problems, you guys know what you need to know in order to solve the problems. You just need to know the formulas, and that's basically what these videos are going to be about. Okay, and by the end of this this lecture, I need you to be able to identify the difference between area and volume, and obviously, I need you to be able to calculate the volume of a cylinder when given the height and the radius. Alright, so, have we heard the terms area and volume before at some point? Yes. Okay. Now, there are several differences, ladies and gentlemen, between area and volume, but there is one major difference between the two that I'm hoping you will keep in mind moving forward. Okay, so area refers to the space inside a 2-dimensional shape. Okay, so if you take a look at this rectangle here, a rectangle is a 2-dimensional shape, and when I ask about the area, okay, I'm not talking about the distance all the way around. Okay, that's the perimeter. Okay, the area, ladies and gentlemen, is the amount of space inside that 2-dimensional shape. Okay? Volume is very, very similar. Okay, the only difference is, instead of talking about 2-dimensional shapes, okay, volume refers to the amount of space inside a 3-dimensional shape. Okay, and you guys don't have to worry about copying any of this down as of now, because it will be in the video. Okay, so both terms refer to the amount of space inside of a shape. It's just one refers to 2-dimensional shapes and the other refers to 3-dimensional shapes. Okay, now a rectangle like this one here, okay, shapes with area, like I said, they only have 2 dimensions, okay? They have width and they have length. Whereas shapes that have volume, okay, yes, it's true that they do have the dimension of length, they have the dimension of width, but they also have the 3rd dimension of height. Okay, which is why we refer to shapes with volume as 3-dimensional shapes. Okay, 1, 2, 3 dimensions. Whereas over here, this rectangle, only a 2-dimensional shape, the dimension of length, the dimension of width. Okay, so this right here is the main difference between area and volume that I would like for you to do your best to keep in mind, or at least know that if you forget, you can come back here and relearn it. All right. Let's kind of ignore all of this down here, okay, and let's just focus on what exactly is a cylinder. Well, you guys should be familiar with, you know, objects in real life that are cylindrical, okay, or in the shape of a cylinder. Okay, I know just about everybody on this team, you know, drinks those giant Monster energy drinks, or those giant, you know, Rockstars, Reign, Venom, whatever it is that you end up drinking. Okay, or, you know, soda from cans. Okay, those cans that your drinks are in the shape of a cylinder. Okay, and that is probably the most, you know, common example that we can all think of when we think of things that are cylindrical. Now, there's a couple of different ways that you can think of cylinders. Okay, here's one of the ways that I like to think about it. Okay, a cylinder is a couple of shapes put together. Okay, if you were to take this rectangle right here, okay, and roll it up into a tube, okay, so that it's like a paper towel roll, okay, you just like roll it up into a tube, and then you place one of the circles on top and one of the circles on the bottom, you end up with a cylinder. Okay, this shape over here on the left, right here, is a cylinder. Okay, and over here on the right, we have a triangular prism. Now, I want you to take a look at both of these shapes that I'm rotating on screen here. I would like for you to take we'll take 1 minute. Or, no, we'll take 2 minutes. And I want you to type one difference that you see between these two shapes. Okay, now don't hit enter or send your message until I say so. Just get your answer typed, and then we'll all hit enter at the same time, and then we'll see what everybody put. Okay, so 2 minutes, and I want you to tell me one difference that you see between these two shapes. Remember, do not hit send Or do not enter your message yet. Okay, not until the time is up. And remember, it's just about participating, okay? You don't lose points, or, you know, you're not going to be ridiculed if your answer's not correct, okay? But just type your answer, okay? But don't hit send yet. Oh, that's alright, Chris, no worries. That's okay, no worries, you're good. Okay, for those of you who are still working on your answer, we have 50 seconds. 50 seconds. It's alright, man. No worries. No worries. Okay, 20 seconds remaining. Okay, let's hit enter in 5, 4, 3, 2, 1, go. Okay, one has a triangle and the other one is a circle. That's good. Okay, we have corners, edges. Triangular prism has corners and the cylinder does. Yes, okay, so we have hit all of the points that I wanted you guys to hit. Okay, so let's focus on the corners first. Okay, or the edges. Okay, because the number of sides and edges you have should correspond with the number of corners that you have, right? So if we take a look at the prism, how many sides do we have? How many sides do we have? Correct. We have 3. How many corners do we have? Or just from the top, I'm sorry. So like just at this top side right here. Yes, perfect. Now watch what happens. What I'm going to do is, instead of having 3 sides, I'm going to increase it to 4 sides. Let's see. Well, it looks like we've changed to a square, right? Because we have 4. We have 4 sides now. Okay, let's change it to 5 sides. And let's change it to 6 sides. And 7 sides. 8 sides. 9 sides. What's happening as I add more and more sides to this thing? What do you think? Yeah, it's getting rounder. Yeah, it's becoming more circular. Yes. Can we agree that the prism on the right is starting to look more and more like the cylinder on the left here? Yeah, I would say so. Let's add a few more. So 10, 11, 12, 13. Okay. 14, 15, 16, 17, 18, 19, 20. Okay, and that's as many sides as it will allow me. Okay, and we almost have transformed this prism into a cylinder. Okay, and a cylinder, it basically has so many corners. It has an infinite number of corners, and that gives it that perfectly rounded shape that you guys see. Whereas here, the prism, it almost looks... Let me zoom in. It almost looks like it's perfectly round, right? But you can still see that it has edges to it. Okay? So, a cylinder, because it has this circular shape to it, it has an infinite number of sides and edges. Okay, which I think is pretty crazy. Now again, because of that circular base and bottom, we have to apply a couple of things about the circle that are taught at earlier grade levels to the formula that we're about to learn that deals with the cylinder itself. So there's two words that I need you guys to be familiar with. Okay, the first is radius, and the second is diameter. Okay, now down here in pink, I have the definition of radius the way it would be written in a textbook. And then in black, I have the student-friendly definition. Okay, so if I were, teaching this to a 7th grader, I would teach them both, but I would focus primarily on this one that I just highlighted because it's more student-friendly. So the radius of a circle, ladies and gentlemen, is the distance from the edge of the circle to the center of the circle. Okay? So it goes from the edge to the center. Okay, and the student-friendly version of that is, it's the distance halfway across a circle. Okay, so when you see a line like this that goes halfway across the circle, that is the radius. And actually, if we go back here, I believe it had, see this line right here at the bottom in pink? It goes from the edge and stops at the center. That is the radius, and that is what the R stands for. Okay, here in orange, the diameter. Okay, and the student-friendly definition of the diameter is, instead of it being the distance halfway across the circle, it's the distance all the way across the circle. Okay, so the distance from one end of the circle to the other. Okay, but it must pass through the center. Okay, and those are the two terms that I need you to keep in mind as we move forward. Okay, because there are some people who are making your spring tests. There's a way that they can make problems related to the cylinder and the cone to where the questions turn into tricky trap questions. Okay, they're trying to confuse you. But if you can memorize both of these, okay, and it doesn't have to be right this second, but by the time that we are done with all three of our shapes at the end of the unit, if you have them memorized and you know what the traps look like, they won't fool you. Okay, and most of the time, my students do not fall for the trick questions. Okay, so the radius is the distance halfway across the circle. The diameter is the distance all the way across the circle. Okay, now, I am, okay, personally, not, when I was a student, I was not a fan of geometry. Okay, like, it felt like geometry was the branch of math that I had the most trouble with. And it was because I'm really not much of a visual learner. Okay, I really don't need to see things in real life in order to learn what they are. If you give me a verbal or a written description, that's really all I need. And I feel like my brain overthinks things when I see them. Jaden's not a fan either. Yeah, I don't know what it is. It's just, geometry with my brain, it's not something that usually works. Okay, however, a lot of my classmates, when I was in school, loved geometry because they were visual learners. And they did they did enjoy the fact that they could see the shapes that they were dealing with, as opposed to just having it described to them on paper. What I have learned, though, is that whether you like geometry or not, there is one good thing that benefits everybody in a lot of geometry problems, and that is the fact that you get to work with what we call a formula. Okay, and I'm a visual learner, I'm just not a fan of it. Yeah, it's, it's a completely different, skill set that needs to be developed, and I had to develop it too, and I wasn't a fan of it even afterwards. But one of the things that I did learn, like I said, was when you're dealing with shapes, you get to deal with formulas. Okay, and formulas are awesome because they're basically a math recipe. Okay, where you just plug in information and then it becomes like a 6th grade level problem because all you have to do is follow the order of operations. So formulas basically ensure that most of your problems are going to work the exact same way. The only thing that's different is the values that you plug in. Okay, and I like that because there aren't, like with a formula, okay, it's like, okay, I always plug, this information in for this letter, this information in for this letter, this information here for this symbol. And once you get into the rhythm of it, it just makes the problems so much easier. Okay, let me show you what I mean. So, what we have here is, okay, we have a cylinder. We've been given the height and the radius. And, ladies and gentlemen, that is all the information we need in order to calculate the volume, okay, or the amount of space inside the shape. Okay, the volume of a cylinder is equal to pi times the radius to the power of 2 times the height. Okay, so pi times the radius to the power of 2 times the height. Let me write that one more time. So pi times radius to the power of 2 times the height. Okay, and this formula never changes. Whenever you're dealing with a cylinder, this is the formula you use. Okay, it's not one of those things in math where it's like, well, for some cylinders you do this, and other cylinders you do this. No, it's always the same formula every time, and that's something that I've learned to appreciate about them. Okay, and now, just like a recipe, we're just going to plug in our ingredients. Okay, so what are we going to plug in right here for our height? What are we going to plug in for H? What do we think, folks? Are we not sure? Are we taking a while to type in our answer? What's going on here? What are we going to plug in for H? Remember, H stands for height. My brain is mush. Mine is too right now. Yes, we're going to plug in 12 because the problem tells us that the height of this cylinder is 12. Okay? What are we going to plug in for the radius? Right, we're going to plug in 5 because the problem tells us that the radius is equal to 5. Okay? So let's do that. Let's just plug in the information that has been given to us. Okay, so V equals pi, and we'll come back to that, times, and instead of using the letter R, okay, we just said we're going to plug in 5. So instead of it being R to the power of 2, it's 5 to the power of 2. Okay, and instead of using the variable H, we're going to use 12. That's okay. That's okay. Okay? You guys with me so far? Is this making sense up to this point? If not, let me know and I can clarify things now. Okay. So every time we solve one of these things, folks, you're going to begin each problem, like it says up here, begin each problem by plugging in the information given to you by the problem. Okay, so we plugged in the value for the radius, plugged in the value for the height, and now there's just one last value that we've got to plug in. And for those of you who have not dealt with the circle before, you may not know the answer to this next question. Okay, and if you don't, that's okay. Okay, but for those of you who have, again, I'm not going to put anyone on the spot. Okay, but I would just like for you to guess, if possible. Does anybody remember what value we plug in for pi? Does anyone remember what value we plug in for pi? No. I forgot. Yeah, it's okay. It's been a while, I'm sure. Okay. Let me see if I can jog your memory. It starts with a 3. I'm gonna guess 1. That's not a bad guess. It starts with a 3. And then has a decimal. 3.14. There it is. Very good. Okay. And so, you might be wondering, Mister, is it always 3.14? And the answer is yes. When we deal with pi, we will always plug in 3.14. Okay? That does not change from one problem to the next. Okay, and so now to find the volume, okay, so volume equals all of this. And now we have gone from an 8th grade level geometry problem to a 6th grade level order of operations problem. Because all we have to do, folks, is use the order of operations to simplify this, and we'll be done. Okay? So when I look at this expression, I see that we have multiplication in 2 spots, and we have exponents. Which one comes first in the order of operations? Do we deal with exponents first? Do we deal with multiplication first? Which one? Yes, Chris is correct. We are dealing with exponents first. Okay? And so I need to warn you. Okay, remember, 5 to the power of 2 is not 5 times 2. Okay, so if you put that 5 to the power of 2 is 10, that is going to be incorrect. Yes, it is 5 times 5, which is 25. Okay, so 5 to the power of 2 becomes 25. And then let's just bring down everything else. 3.14 and 12. Okay. And now, all we have left is multiplication. So, let's just multiply from left to right. It's the only thing we gotta do. So, we are going to have to kind of remember that we are multiplying decimals here. So, let's see. Let's do 3.14 on top. 3.14 times 25. And remember, because we're multiplying, we do not need to line up the decimals. Okay, so 5 times 4 is 20. Carry the 2. 5 times 1 is 5, plus 2 is 7. 5 times 3 is 15. Okay, I'm just going to cross that out. Put a 0. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Add everything together, and we get 0, 5, carry the 1, 8, and 7. Okay, now how do I know where to put my decimal in the final answer? How do I know where to put my decimal in the final answer? Okay, if we were adding and subtracting the decimals, yes, we would bring it straight down. But because we're multiplying, multiplication has its own, like, special thing that happens. Yep, count the numbers that are behind it. Okay, so we have 2 numbers behind the decimal. Up here in 3.14. And we don't have any down here in 25. Okay, so, yes, Annadelle. So, yes, we get the decimal and it goes right here. So we have 2 numbers in our problem behind a decimal. That means we need 2 numbers in our final answer behind our decimal. Okay, so we just multiplied those together. And now we just need to multiply this by 12. Okay, so 78.5 0.50. And we'll bring down the 12. And once we're done doing this, we're done with the whole problem. Okay. 2 times 0 is 0. 2 times 5 is 10. Put the 0, carry the 1. 2 times 8 is 16. Plus 1 is 17. Carry the 1. 2 times 7 is 14. Plus 1 is 15. Oop, I don't know why that happened. Come down here, put the 0. 1 times 0 is 0. 1 times 5 is 5. 1 times 8 is 8, and 1 times 7 is 7. We add them all up, and we get 0, 0. 7 plus 5 is 12. 1 plus 5 is 6. Plus 8 is 14. 1 plus 1 is 2. Plus 7 is 9. Okay, and how many numbers do we have behind decimals in what we just multiplied together? Yeah, right, just the 2. And so as Chris just said, our final answer is going to be 942. And just so that we know that this is our final answer, I'm going to do this. Okay, and it actually just occurred to me that I did not put units for this, and Mr. Baca would be very disappointed in me if he knew that that were the case. So we'll just pretend that this is 5. We'll put 5 what? Centimeters? Go with feet. So we'll say this is 5 feet, and this is 12 feet. So the volume of this cylinder is 942 feet. Okay, so let's go ahead and jot down our formula. Okay, so the volume of a cylinder is pi times the radius squared times the height. Okay? Now, I want you to think of... You're confused as to where pi came from, honestly. We could talk about that at the end. I think it's actually something that is quite interesting, and it's one of the things that makes the circle the weirdest shape out of all the shapes that exist. But yeah, we can talk about where pi came from. But let's get through the examples. That is something I'd like to cover, though. Okay, so the volume of a cylinder equals pi times the radius squared times the height. And I want you to think of this formula here. I want you to think of this formula as a recipe. Okay, because we're going to learn other formulas too. When we talk about the cone has its own formula for volume. The sphere has its own formula for, the volume. Cubes have the formula length times width times height. And then, let's see, what's another? So like for area, we could do base times height over 2 for triangles. So all of these formulas, okay, that you guys have learned, like for area of finding the area of a square, finding the area of a rectangle, finding the volume of a cube, and finding the volume of whatever it is that you've learned to find the volume of. These are all recipes for very specific shapes. Okay, so we need to make sure, first and foremost, that we are using the correct recipe and the correct formula for the correct shape. This is the formula for the volume of a cylinder, and this is exactly why we're using this formula and not any of the others. Okay, so now we need to plug in information into this formula. So my first question to you is going to be, what are we going to plug in here for h? Okay, or the height? What are we going to plug in for h? Yes, we're going to plug in 11. What are we going to plug in for r? Okay, or the radius? Correct. So we're going to plug in 6. And then last but not least, what are we going to plug in for pi? Okay, we just answered this question not too long ago. Good. I'm just going to write it down up here. So 3.14. Just in case. Just in case you look back on this and you're like, wait, where did these values come from? Okay, and we're going to get the equation that Jaden posted in chat not too long ago. So we're going to get, I'm going to try and keep it color-coded for now, 3.14 times 6 to the power of 2 times the height, which is 11. Okay, now we've got everything plugged in. We know the volume is going to be equal to all of this. So now we need to calculate all of this using the order of operations, and we will then have our final answer. So what's the first thing we're going to do now that we've got everything plugged in? Exponents. Excellent. All right. So 6 to the power of 2. What is that going to give me? What is 6 to the power of 2? I'm just going to write this out real quick. Yes, 6 to the power of 2 is 36. Remember, it is not 12. Okay. I just said 12 and then I started to write 12. We had to kind of revisit what exponents are in first period today. Okay, but remember, 6 to the power of 2 is 2 6s multiplied together. Okay, so 6 times 6, which gives us 36. Okay, now what? We've taken care of our exponents. Now what do we do? So we have divide. I don't see any division here, though. Okay, I only see multiplication. Yes. Yeah. So let's go ahead and multiply, because that's all we have left. Okay, so let's work from left to right. I'm going to get rid of that right there. And let's just, just like I said, let's multiply from left to right. And we'll start by multiplying these two together. Okay, and again, this is the reason why we reviewed multiplying decimals before we started doing any work with our 3D shapes. Okay, we'll use purple. There we go. Now, let's just multiply. So 6 times 4 is 24. Here are the 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. So we've multiplied everything by 6. Let's move down here, add a 0. 3 times 4 is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. And then 3 times 3 is 9. Add it all together, and we get 4. We get 10. We get 13. And we get 11. And now, we just need to figure out, okay, where is the decimal going to go in this answer? Where's my decimal going? What do we think? Between the 3 and the 0. Excellent. Okay, how did you know that? Okay, how do we know that this is the correct spot for the decimal? The number behind the decimals on the top. Yes, perfect. If we take a look at the two numbers we just multiplied together, or the two values, we've got two numbers behind decimals up here in the question, and that means that our answer, we need to have two numbers behind the decimal as well. Good. All right, we have one last step, and then we are done with this problem. What is the last step before we're done and we will have calculated the volume of this cylinder? What's the last thing we have to do? And we just multiplied these two together to make 113.04, and we have one last step. Times 11. Perfect. We've multiplied these two together, and now we just have to multiply by our last number. All right, 1 times all of this is just going to be 1 times 4 is 4, 1 times 0 is 0, 1 times 3 is 3, 1 times 1 is 1, 1 times 1 is 1. Okay, move down, do a 0. It's going to be the same thing. 1 times 4 is 4, 1 times 0 is 0, 1 times 3 is 3, 1 times 1 is 1, and 1 times 1 is 1. Add it all together, and we get 4, we get 4, we get 3, we get 4 again, we get 2, we get 1. And we put our decimal right here. We have two numbers behind decimals up here. So our final answer needs 2 decimals as well. And then, okay, we can't make Mr. Baca mad. We've got to make sure that we have the correct units. So let's put an M for meters. And just like that, we are done. So a cylinder with a height of 11 meters and a radius of 6 meters has a total volume of 1,243.44 millimeters. Any questions about this second example? Okay, now these problems don't normally take this long. Okay, I'm just going over step by step to make sure that, we have an idea of what we're doing. And take a look at this. Okay, this really isn't, I know it takes up a lot of the page, so it might look like a lot of work, but it really isn't. It really is not a lot of work. And, you know, these problems can be done just insanely quickly. Or insanely fast, rather. Okay. Let's do the... let's do the 1 minute thing again. So we'll type our answer, but we're not going to send it until I ask for it. Okay, there is something different about this problem. Okay, this is the trap question. Okay, and what I'm going to do is put volume equals pi times the radius squared times h. I want you to take a look at this problem, okay, and without sending your message or your answer until I ask you to, I want you to type your answer in, and then we'll all submit it in 60 seconds. All right? So starting now. And you guys are correct. Okay, on the shape, we have diameter given to us this time instead of the radius. Now, if you look at the formula here, the formula does not have diameter listed as one of the ingredients. Okay, we have pi, we have radius, and we have height. Okay, not diameter. Okay, and what the people who make these problems think you're going to do is, they think that you're going to take diameter and you're going to plug it in for the radius. Okay, which will guarantee that you arrive at the incorrect answer. Okay, so it is a trap question. Now, you can still, if you know the diameter, you can make a change to this problem to where you can solve it. Because if you know the diameter of a circle, you also know the radius of that circle. What is it we can do to that diameter in order to change it from diameter to radius? Yep, we're gonna cut it in half. Okay, so we know if the distance all the way across a circle is 14... Okay, oh, once again, I forgot my units. So let's go ahead and add those. Let's go with centimeters this time. Okay, if we know that the distance all the way across a circle is 14 centimeters, then that means all we have to do is cut this in half, and we will know the distance halfway across it. So we'll know the radius of this circle is equal to 7. Okay, and now we have all the ingredients that we need in order to solve this problem once again. Okay, so we know the height will be 5. We know the radius will be 7. Then we know that pi is going to be 3.14, like it always is. Okay, that does not change from one problem to the next. Okay, so 3.14 for pi, always. Okay, and now, just like that, you have avoided the trap, you've avoided their trickery, and you could now just treat the problem like it's, just like all the other ones. Okay, so be careful. Some people will make problems where they give you the diameter instead of the radius. And if they do give you the diameter, just cut it in half and plug that value in as your radius. And then the problem works exactly the way they have up to that point.